All right, we're heading on to part 2. Analyzing reasoning. You will frequently use inductive reasoning to make conjectures. You will use deductive reasoning to show that conjectures are true or false. Okay, I don't know about you guys, and you may think that I'm saying it too much, but my mind is starting to get full of vocabulary words. But we really need to know which type of reasoning is being used, either inductive or deductive. Okay, what conclusion can you make about the product of an even integer and any other integer? If you remember, product is multiplication. Even integer, that's 2, 4, 6, 8, 10, 12, on and on and on. An integer is a whole number, and any other integer. Okay, even integer and any other integer. And we just have to start making guesses and writing down ideas. Okay, this is the problem. Like right here in front of you is the problem. There's no numbers there, and that might confuse some of you. But just start making some guesses and look for patterns. So I'm going to look for some patterns. I'm going to do a whole bunch of stuff times 2. So we're going to do times 2. I'm going to do a few of them. And 2 is going to be my even integer. Okay, let's try, I don't know, negative 2 times 2. Let's try a positive 2, a positive 4, a 10. Okay, negative 2 times positive 2 is negative 4, 4, 8, 20. All right. What if we made our even integer a negative? Let's test again. So let's do all of them negative 2s. And actually, I noticed that we didn't multiply any odd numbers, so let's do this. Let's do a negative 2, a negative 1, a 3, and a 6. Let's do all that multiplication. So here I have a positive 4. Here I have a positive 2, negative 6, negative 12. Okay, can you make any conjectures from the data that we've sort of gathered? Well, I've got some positives and negatives, no big deal, but every single one of my answers, no matter if I'm multiplying by even or odd, okay, all of my answers are evens. So my conjecture is an even integer times any integer equals an even integer. Okay, let's move on. Oh, I left a page. All right, another example. Decide whether inductive or deductive reasoning is used to reach the conclusion, and explain your reasoning. Each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. Okay, we're going to say this one is inductive reasoning, because we used a pattern to reach our conclusion, to reach our reach our conclusion. Next one. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Okay, this one is going to be deductive reasoning. I'm having an awful time writing this morning. I'm sorry. Deductive reasoning. Okay? Facts about animals. And laws of logic are used to reach our conclusion. All right, you try. Use inductive reasoning to make a conjecture about the sum of a number and itself. Okay, the sum is addition of a number and itself. Then use deductive reasoning to show the conjecture is true. Okay, try, just please, write down some numbers, see if you can find a pattern, see if you can make a conjecture, okay, and push pause. Okay, I did some tests, okay, tried some numbers right here, made a conjecture, and then said that it's deductive reasoning because n plus n is a number, n is a number, n plus n is 2n. You try. Give an example of when you used deductive reasoning in everyday life. Sit back and get imaginative and give an example of when you use deductive reasoning in everyday life. My example. When it's raining, I bring an umbrella to school. Today, I didn't bring an umbrella to school, so it must not be raining. Very exciting, I know. Hopefully you came up with more exciting examples. Daily homework quiz. You can look at these, push pause for a second. I'm going to write down some answers and we'll go over them in the morning. There we go. Use the law of detachment to make a valid conclusion in the true statement. If two angles are complementary, then the sum of their measures is 90 degrees. Angle C and angle D are complementary. Therefore, the measure of angle C plus the measure of angle D is 90 degrees. Yep. Use the law of syllogism to make a valid conclusion in the true statement. If water is at room temperature, then it is a liquid. If water is a liquid, then it's not frozen. Therefore, if water is at room temperature, then it is not frozen. Yeah. Last few. This is the last slide. So use the true statements below to determine whether the conclusion is true or false. Explain your reasoning. If Janine does her homework, then she goes to the movies. If Joaquin goes to the movies, then he buys popcorn. If Janine goes to the movies, then she buys popcorn. Janine does her homework. Goodness, that's a lot of stuff. If Janine does her homework, then she goes to the movies. Okay, I'm skipping Joaquin. If Janine goes to the movies, then she buys popcorn. Janine does her homework. I'm going to skip that part too. I think we have way too much information in this paragraph. So, oh no, I'm not skipping that one. Sorry, that's valid. That's part of the thing. So Janine does her homework is the first hypothesis. Therefore, yeah, Janine buys popcorn. Oops, that should be in green. Hold on. Erase. Okay, that is very, very true. Okay, and that is the law of syllogism. My handwriting, there we go, sort of. So yeah, it's true. Okay, now let's back up. If Janine goes to the movies, then Joaquin goes to the movies. Yeah, Joaquin, that was like random information in a paragraph. There's no logic law that applies to Joaquin. No law of logic. I didn't even underline it because Joaquin going to the movies had nothing to do with the whole law of syllogism for Janine. All right, good work today.